Hi everyone. So in this video, we'll be walking through the question replace X. And in this function, we're going to take in a tree T and return a new tree with all labels X replaced with 0. So this is important to note that we're returning a new tree and we are not mutating the original tree. So before even getting started with code, let's walk through this example. If we called replace X on the following tree and we're replacing all the values of 2, first, we would look here, we would change this label to 0, then we would look through all of our branches. We see this label is also 2, so we change that to 0. And then we go through this branch, we see that this one's 2, so we also change that to 0. And finally, we have another 0 over here. So this would return a new tree that's seen over here, where all of the labels of 2 are now 0. So we can consider how we can use recursion to loop through all of the branches of the tree. The way we did it in that example, first we considered the root node label, and then we looked at all of the branches. So one thing that we can do is use a for loop to go through all of the branches and basically break our tree up into multiple trees where we just continue checking the root label of the. We want to apply this function to each of the branches. And what we can do is actually use a list comprehension to loop through all of the other branches, and we can store this information in like another thing called, it would be like a new branch list. And then when we do our recursive call, what we can do is, since we're only looking at the root label, we can check the root label. And then if it's equal to the amount that we want to, if it's equal to the label that we want to change, then we return a new tree that changes that label and then now looks at all of the other branches. So check the root label. If equal to target amount, to target label, return new tree with changed label, or we know it will be 0, so with label 0. Otherwise, keep the existing label. Okay, so now we can start writing our code. We know that we want to apply this function to each of the branches. So that means we'll be using a list comprehension. So we can have a variable new branches, and this will be equal to the function, the function, we'll be calling the function replace X on each of the branches in our tree for B in branches T. And this is because we want to call this function on every single branch. We don't want to just apply it to all of the branches as a whole. We want to recurse through each branch individually, which is why we have this for loop that goes through it. So now we want to be checking our root label. So that's what our condition here will be. So if the label of our tree is equal to X, which is our target value, now we want to return a new tree. And since our tree will have a root label and then the rest of the branches, we know that we already created our new branches in the line above. So then we can simply return a tree that has 0, since 0 is the new label that we want, and new branches as the rest of our branches. And the reason this works is that since new branches already calls replace X on itself, then we know that this new tree will also be sure to have all of the replaced values as well. And if the case that the label of the tree is not equal to X, we don't want to change anything. So we keep the existing label, but we still want to return a new tree because remember, we are not mutating the original tree. So even in the case when we don't want to change the label, we still have to return a new tree. And we would have tree with the original label, and then we would still call new branches. because we still need to go through and check all of the other branches. So that would be the implementation for this problem. But one other thing to check is that, say we are in this tree and now we get to this label right, or like this node right here. We know that there's no more branches. So what will happen to our new branches call? So our new branches call actually just won't do anything because there's no more branches in B. So it'll just be an empty list. And when we have our recursive call, it won't have anything left. So that's how we don't need an explicit base case to check the length of our tree, since it'll just end when there's no more items in new branches. So this is a common kind of like approach to tree recursion where if you need to apply a recursive function to each of the branches, you can use list comprehension for that. And then otherwise, you would check the label of your root, and then you would return your new tree, and then through recursion, like your new tree would return this final tree with all of your updated labels. So that's replace X. I hope this video helped.